Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, dear students. Welcome back to this TV Learning Series program. As I'm Teacher Patrick, as usual, and I'll be taking you through, or we go through together, Senior 1 Chemistry. And you remember in the previous lesson, we're looking at the Unit 4, which is about the pure substances and separation of mixtures. So we are still on the same unit today, and the lesson we'll be looking at the separation methods. It is the continuation of other methods that we have looked at. I hope you still remember some of these methods that we looked at together in the previous lesson. So today, we'll be looking at other methods, that is simple distillation technique. We'll look at the fractional distillation technique, and then we'll look at the paper chromatography technique, and then evaporation and crystallization if time allows. Before we look at the simple distillation, let's first remind ourselves of what we looked at in the previous lesson. And we'll start with the simple exercise. Let's come back to this one. So when you look at the exercise, it is asking us to match the following. So we have the mixture, and then we have the method of separation. So we are asked to simply match the mixture and the method that is used to separate that mixture. So let's look at the right away start with our exercise, and then we work it out together. So when we look at the part A, it is ammonium chloride with the sodium chloride. Ammonium chloride with sodium chloride. And then we're asked to look at the methods among all these methods. These are the methods that are used. And then we see which method we match this one with the method that can be used to separate this mixture. I'll just give you some few seconds to do that. Very good. So when you look at the ammonium chloride and sodium chloride, these are substances. So we'll have ammonium chloride and sodium chloride will be sublimation. Why sublimation method? Because we are saying that ammonium chloride sublimes. If you remember what we talked about the sublimation, we said a substance is able to change from the solid into the gas without passing through the liquid state. So that is the sublimation. So in this case, ammonium chloride sublimes and sodium chloride remains behind. So that is why we are choosing sublimation as a method that can be used to separate ammonium chloride and sodium chloride. Let's go to the second one, part B, sand and water. I hope this is very obvious. Sand and water. Which method can you match and see whether we get the same answer here? Just a few seconds again as we go through. So check to see whether you have the same method, which is filtration. Why have we selected filtration in the first case? Because sand and water the sand does not dissolve in water. So when you have the sand and water, the sand remains in the solid state, and the water remains also in the liquid state. So when we filter, the sand remains behind, and then we'll have the water moving down filtered. Do you remember even those substances? The substance that remains behind after filtration is called what? Do you remember it? I hope you still remember. That is a residue. So the residue in this case is the sand. And the water is the filtrate. Let's go to the sea, which is beans and sand and sand. Beans just poured into the sand by accident. What do? This is very simple. Just do the picking or the sorting. One by one. Just pick one by one, and then you separate. So which physical property here do we use here? So we are just, the sand and the beans do not have the same sizes, so that is why we are using the sorting. Let's go to the iron powder and the sand. Iron is a metal, but it is in powder form, and the sand. So this will be magnetization, because the iron powder, being a metal, attracts the magnet, and then the sand doesn't. So when you use a magnet, it will pick out the iron powder. Water and cooking oil. So of course, we have all exhausted other methods. So the method that is remaining is only the decantation. And we said here with the decantation, we are using a separating funnel. You remember what we looked at this one together when we were separating water and cooking oil. So this is called decantation or use of separating funnel. So here we are, number 2. They say state the physical property on which the method depends on. The physical property, each of these methods has its physical property. So when you look at this, at the filtration, which physical property we are using here? We are using the solubility here. Why the solubility? Because we have said if we say sand and water, sand doesn't dissolve in water. So that the physical property here we are employing is the solubility. Ammonium chloride and sodium chloride. So we can state that one, that is ammonium chloride, and this one, that is sublimation. The change from solid to gas. The physical property here we are using beans and sand is the size of the particles. So using the size of the particles. Size of the particles here. And then if we go to the iron powder and the sand, we are using the magnetic property. So we are using the magnetic property. So one of the substances, which is iron powder, is attracted by the magnet. So that is the magnetic property that we are using. Water and cooking oil. So here, water and cooking oil, they don't mix together. So we can still use the solubility, or dissolution, These are the physical properties that we are using. So right away, I hope we have the same answers together. So right away, let's move to the simple distillation technique. In simple distillation technique, we have it over here. This is the diagram that we have here. So we have the salt solution. We have the flask here. And then we have the heat. We have the liming. This flask is connected to the liming condenser. And then you have the cold water which is entering. And then you have the hot water getting out of the liming condenser. Then we have the distillate, which will be the pure water. So when you look at this, what are we trying to separate here? Just tell me what are we trying to separate in this method? We are just using, this is the salt solution. So you have the salt, and it is dissolved in water. What do? So you have to distill the water. So you know salt water, as it is salty, you know, it is not, when you're drinking salt water you don't feel comfortable. The taste of the salt water is not good for drinking. So here, when you want to separate the water, that is the sea water, because the sea water is salty, so we are using this simple distillation. So here, this is one of the methods, the mixtures we are looking at is the sea water. Now you have the sea water. You can also use this method to separate the sea water from the salt that is dissolved in it. So here, the principle that is employed, before we look at the principle, another method, another mixture that can be used is, that can also be employed in this simple distillation is you can use even ethanol and water. So we are looking at the boiling point of these substances. When you heat the salt solution, the vapor comes out. So you have the vapor of that is the water which is coming out. Now this vapor, as it comes out, it enters into the Liebig condenser. So as it enters here, then it is condensed. After being condensed, so you remember the salt has a low boiling, but the salts have high boiling point, and so they remain behind. And therefore, you will have the water, which is the vapor here, and then distilled into the pure water. So this is the simple distillation. So simple distillation is the technique used to separate mixtures, with high difference in boiling points. That is, we have the ethanol and water as a simple example. Ethanol boils at 78 degrees Celsius, and water boils at 100 degrees Celsius. So there is a big difference in the boiling point. So we can use this technique to separate. So distillation itself simply means that if we say distillation, this is just evaporating or heating the liquid to form water, to form vapor, and then condensing the vapor to form the liquid again. You remember, you heat the liquid. Here we had the mixture, which was in liquid form, that could be a solution. Then the water evaporates, and then it is condensed. That is the purpose of this Liebig condenser. It is condensed and then corrected as pure water. So the salt remains behind in this flask. So that is the simple distillation. So we can proceed and move to fractional distillation. So the fractional distillation is somehow similar to simple distillation, only that the substances here to be separated, must have cross. This is a very important note to consider, that the substances to be separated here must have cross boiling points. Cross boiling points. In this case, you have, or either even, we can use also, but ethanol would not be the best, because even simple distillation can also work on the ethanol. Even fractional distillation can also work. But here, in the fractionate, here we have the fractionating column. So probably this method works best when you have substances like components of air. Like components of air, where you have either oxygen, you have nitrogen, and then you have either or argon. These are substances, they have very close boiling points. So this method is best suited to the substances with close boiling points. Oxygen boils at negative 183 degrees Celsius. Nitrogen boils at negative 196 degrees Celsius, whereas this argon boils at negative 185 degrees Celsius. These are substances with very close boiling points. So these components of air can be separated by this method, which is fractional. Fractional means that it is corrected in fractions, the substances. So when you have the components, you have oxygen corrected, you have the lowest boiling, nitrogen corrected, argon corrected, and then oxygen corrected later on, depending on their boiling points. So this one uses also the boiling points, but which are very close. This method depends on the boiling point as well as the property that we are basing on. So here, in this method, what is the purpose of the fractionating column? So the fractionating column is the one that fractions these substances so that we can be able to correct these substances here in form of fractions. So that's why it is called a fractionating column with a thermometer, because you remember we said that this depends on the boiling point of these substances. So we can also look at the other methods that can be used. Crude oil components. Crude oil components. So when we talk about the crude oil components, there are so many of them. We have petrol, we have petrol, we have gasoline, we have gasoline. So we have gasoline, we have even natural gas, and many others. So these substances have cross boiling points. Those are the components of crude oil. They have cross boiling points. So they can be separated. They can be separated by fractional distillation. What does it depend on? It depends on it depends on the boiling point of the substances. But those boiling points must be close together. Close together. We have given an example of the components of air, where we have oxygen, nitrogen, and argon with very close boiling points. So the fractionating column will separate them in that form by putting them in fractions and then corrected as a distillate. So we'll just move straight to another technique that we have looked at, that we are supposed to look at, which is paper chromatography. Paper chromatography. You'll allow me to remove this one, and then maybe look at the paper chromatography in the next step, which will be another method that can be used to separate components. These separate components, I have to remove this one for the meantime. I hope you were taking note, and therefore you have it in your note. So this is the paper chromatography. So this is the technique, the separation method, separation of mixtures by using the stationary phase and then the chromatography, and that is what we call the paper chromatography. We have different types of chromatography, but we are going to look at only one chromatography, which is paper chromatography. The materials, what do you need when you are preparing, when you are going to select, to separate using the paper chromatography? You need a stationary phase. So in the stationary phase, you will need, that is a paper. So that is what it is called, a stationary phase. That is the paper. Not any paper like this one. We'll see the type of the paper that is required. Then you need a mobile phase. That is a solvent which is moving. And then you have the sample. And in most cases, the samples have to be colored. In most cases, but not always, in most cases, this separates colored materials. What is the technique that you have to employ? You have the paper, you cut the paper, which is the stationary phase, and then on the paper, put a line with a pencil. Or you put a line, or you can use a pencil, you put one line and another line. That line is called the start point, and another one. It can be in its rectangular form or in the square form. And then on that paper, on the start point, you have to put a drop of the sample that you are going to separate. This sample, in most cases, I said it has to be colored. And then, after putting the sample, you insert the paper with the sample slightly above. Part of the paper is dipped into the mobile phase. That mobile phase is a solvent. And then you have the sample slightly above the solvent, and that is the stationary phase, which is the paper. What happens when it is inserted? The substance at the start point, which is inserted in the mobile phase, will start, this materials within the mixture will move. So they will start moving up. We call it a vertical method. So it will start moving up, migrating. This migration will depend on the solubility of the solutes within that material. So this one uses the solubility. Solubility of particles in the mixture. That is the physical property it depends on. The solubility. So those ones which are very soluble, this one looks like orange. This is somehow red pink, and this is black, this is brown. So the number of spots here indicates the number of components within that sample that is here. So the movement here, if we have 1, 2, 3, 4, so that means in this sample here, there are 3 different components. So 3 different colors. Therefore, that is how it is operated. That's how it works. And then let's look at how the types of the techniques that can be used. The types of the techniques that can be used to, in the samples that we can use. We are still on the chromatography. These are the types of the techniques that can be used. So we have the horizontal technique, and then we have the vertical technique and the horizontal technique. The vertical technique is this one, which was moving. So the horizontal technique is this one, whereby you have the sample here, so it will be moving in a horizontal direction. So this is that paper, the whole of this paper, after separation, is what we call a chromatogram. So how is the chromatogram prepared? You need the type of the paper. The type of the paper, remember I said it is not any type of the paper. We have Whatman #1 filter paper. So these filter papers, if you happen to go into the lab, you'll find they have different types. but we prefer the Whatman #1 filter paper. And then we have the preparation of the paper. The paper has to be very clean so that no other impurities are in there that will interfere with your results. Then preparation of the solute mixture. In most cases, the mixture are added in small quantities, micrograms of the sample, the micrograms in small quantities. Spotting of the solute mixture. So here, this is the spot. So that's where you have to put it. The choice of the solvent to use, that is the mobile phase. We have the mobile phase. So which type of the solvent? There are many solvents. We have the polar solvents, non-polar solvents, and then we have the moderate solvents. In this case, non-polar solvents will depend on what you are going to develop, or you depend on the type of the mixture that you want to separate. So in most cases, we use organic solvents. Those are the non-polar solvents. Like even we can use also ethanol, we can use tetrachloromethane, we can use acetone, and many others. Development of the technique, we have the ascending order. The ascending order is this one. Then we have the descending order where the mixtures will be moving downwards. And then we have the radial development. The radial development is the most common that we use. So the radial development is this one. I put it here, maybe. So in the radial development, you will have the ink. The whole of this one is the filter paper. And then you have the ink in the middle. When you put the ink with the solvent, the mobile phase, so the filter paper is the stationary phase, and you have that would be the substance to be separated. Then you add there the mobile phase. So it will move, the solvent will move with the different solutes and will form rings. This is what we call the radial technique or the radial development technique. So we can use that, we can look at the separation, the applications of this. We have separation of organic and inorganic compounds. That is the technique, that is this. We use chromatogram to separate the organic and inorganic compounds. Analysis of amino acids. But amino acids, take note of this. Amino acids are colorless substances, so we need what we call allocating agent. Allocating agent in this time will be ninhydrin, so it will turn the amino acids into colored substance, and so that it can be easily separated. Separation of carbohydrates and some pigments, colored materials. The chlorophyll within the leaves, within the flower, the colors within the flowers can also be separated by this paper chromatography. So we've not been able to look at the evaporation and crystallization, but that is the one that we'll have to start with in the next lesson. So before I leave, I want to leave you with a homework. Please try this homework and see whether you can be able to do this homework. Number one, what is fractional distillation? What is fractional distillation? That is AB. What property does fractional distillation depend on? Number C, what is distillation? What is distillation? That is 1, 2. State the substance, the name of the substance. The name of the substances that can be separated by fractional distillation. Fractional distillation. Number, that was A, B, C. Number D, what is paper chromatography? What is paper chromatography? Chromatography. With that, if you are able to answer these questions, I hope the lesson would be wonderful. I hope to see you next time. Thank you so much for listening and watching. Bye-bye.